This is lesson 12.6, and this is our last lesson in statistics. We're going to talk about scatter plots, correlation, and regression lines. All right, in this lesson, we're going to change it up just a little bit, and we're going to be looking at two variables. Now, you could read in the book, and they talk about education versus divorce rate, or study time and test scores. So we're looking at two things, and when you have two measures, you could have an X and a Y. When you study 5 hours, you make 82. When you study 6 hours, you make 87. So that would be an X and a Y. When you do that, you end up with data that can be plotted. And you've done this before in an algebra class where you have the x-axis and the y-axis, and you go horizontally in an x direction, vertically in a y direction for an ordered pair, and you plot a point. If you plot a lot of data, you end up with something called a scatter plot. And the TI graphing calculator can do that also. We'll talk about that in class. When you do a scatter plot, there may be a correlation, or they may seem somewhat random. When you have points that form a rising line as you go from left to right, if the line is rising, it is considered a positive correlation. This is a positive correlation, this is a positive correlation, and this is a positive correlation. This one is perfect, this one is considered strong, and this one is considered weak. The more like a line it is, the stronger it is. This set of data would have no correlation. They do not seem to be headed in any kind of pattern. This set, and this set also have correlations. They have negative correlations. Now, that is not necessarily a bad thing. You might suppose you measure study time versus number of questions missed. The more time you study, the lower the number of questions missed. That would have a negative correlation. This is a weak negative. It's a falling line. This would be a pretty strong correlation, and this would be a perfect negative correlation. So remember, if it's rising, it's positive. If it's falling, it's negative. If it's totally random, then there is no correlation. So let's take a look at some of these questions. I'm going to make this larger so we can see the scatter plots. It says make a scatter plot for the given data, and then use the scatter plot to describe whether or not the variables appear to be related. Now, you're not actually going to make this. You're going to check and see which one of these scatter plots matches this data. Well, we're looking for the point 45, 40. So let's check here. 45, 40. Yes. Whoops. Nope. 45, I'm sorry, is right there. And 40, no, the point 45, 40 is not on that graph. That's 50, so 45 is right here. 45, 40, no, there is no point where I have my little dot. And I'm just using the first data value. 45 is right in between there. 40, yes. The point is there. Let's look at the next point. 52, 43. That's 50 a little bit to the right. 43, that's the second point. 62 would be about there, up to 55, yes. And 78 will be just a little to the left of 80, and up to 71, yes. I believe C is it. We could check this one. 45, 40, the first point isn't even there. So this is my scatter plot. Now, do the variables appear to be related? Yes, they appear to be positively correlated. Yes, they appear to be negatively correlated. No, they do not appear to be correlated. You're checking to see if they could be approximated by a line. And I would say yes. And because it is rising, it would be a positive correlation. Let's look at our next one. This is kind of messy, kind of hard to read. All right. The scatter plot in the figure shows the relationship between percentage of married women of childbearing age using contraceptives and births per women in selected countries. So the X is the percent of married women using contraceptives and the births of women. Okay. So even if that's kind of hard to understand, it says use the scatter plot to determine whether there is a strong positive correlation. Well, they have drawn us a line sort of through the data. Is there a strong positive correlation? Hopefully you said no. There is a weak negative correlation. All right. Let's look at the next one. The scatter plot of data from 20 countries shows the relationship between a country's annual per capita income and the percent of people in that country who call themselves happy. Use the scatter plot to determine whether the following statement is true or false. There is a negative correlation between per capita income and the percent of people who call themselves happy. All right, what you want to do is see if you drew a line through it, where would it be, what would it go, and it has to be a straight line. You can't have bends and curves. So, does this look like a negative correlation? And I would say the answer is no. There is a slight positive correlation. It's weak, but it's somewhat rising. Number 4. The scatter plot from 20 countries. Okay, this is just a flip of that last question. All right. There is a positive correlation in this graph. Is there a positive correlation in this graph? The answer is no. These have all been false so far. All right, let's see about this one. In which scatter plot is R? And by the way, I don't know that I said this. It was up in our picture. R is the measure of the correlation coefficient. I need to go over this a little bit more. This was a perfect. The R value was 1. 1 is a perfect positive correlation. If R is negative 1, you have a perfect negative correlation. And negative does not mean bad. It just means as one of them is increasing, the other one is decreasing. All right, as you get closer towards 0, let's look at the positives. If it's about 0.8, it's positive, it's strong. 0.3, weak. No correlation is 0. So the value of R is going to be between -1 and 1. It's going to be between those. R is -1 if it's a perfect negative correlation. It's +1 if it's a perfect positive correlation. 0 if there's no correlation at all. All right, so our question number 5 says, which one of these scatter plots could the R be -0.7? All right, now negative means that it's falling. Well, it definitely cannot be that one, and it cannot be that one, and I don't think it could be C because that looks perfect. F looks too weak to be 0.7. This would be like a -0.3. So let's look at these two. I would say that A is a very strong, it's just a little bit off of this one. This might be a -0.9 because those almost fall into a line. My choice would be B. It is strong, negative, but it's not super strong. All right? And you will just put the alphabet, the letter, and make sure you use capital. All right, now, if data has a correlation, or even if it doesn't have a correlation, you can find what's called the regression equation. It is the equation of the line that comes closest to most of the points. There is little error between the line and the points. Okay, it is a very involved project to do by hand, and we're not going to do that. We're going to do it using our TI calculator, and this is in your note sheet. This is how to get the regression equation. All right, when I get to a problem, I will come back to this and I'll get my calculator out. We're going to be using stat again, and we're going to do something we've not done before. All right, now I'm going to actually show you the scatter plot, even though that is not part of the question. This just says to compute R, the correlation coefficient, using the data. That's very, very easy to do. I will show that first. All right, we go to our calculator. I'm going to clear my home screen. I'm going to go to Stat. I'm going to choose Edit. Now we have put our data into L1 before so that we could do one variable statistics. I'm going to delete all of those. Because I have X and Y, I'm going to use L1 and L2. I'm always going to put X, my independent variable, in L1. So 1, enter, 2, enter, 8, enter, 4, enter, 6, enter, 5, enter. Move to the right. You'll be in L2. And I just lost my problem, so let me go hunt for them. Okay, it's back. So I have my Y's, and I'm going to put these into L2. All right, so I'm going to put in 3, enter, 3, enter, 10, enter, 5, enter, whoops. Let's see, I have 10, 5, 8, enter, 5, enter. All right, and I'm gonna double check. I have 1, 3, 2, 3, 8, 10, 4, 5, 6, 8. It's a little difficult because on the grapher, you're going left to right, but over here, you're going up and down. Okay, so I have my data in L1 and L2. I'm going to go ahead and show you how to get the correlation coefficient. If you, in class, we will have turned something called diagnostic on. So that is important. You won't see the R value if you don't have your diagnostics turned on. I could show you how to do that. We'll do a second quit. From the home screen, you're going to go second. You just do this once and it'll stay this way, of the 0 key. And I'm going to scroll down. This is going to take a little while. I'm going to the D's. Whoops. Okay. I'm going to the one that says diagnostic on. Enter. Now once that is on the home screen, I have to press enter and it's done. Now my diagnostic is on. It will stay on until maybe I change my batteries or I turn it off. All right, so going back, stat, edit, I've got everything in L1 and L2. Now I'm going to go to stat, calc. Now last time we were here, we only had things in L1 and we did a number 1. Now we're going to do what's called a linear regression, linreg, number 4. And I'm going to enter. It double checks how, well, at least this version, my old calculator did not do this. I'm going to just go down to calculate, hit enter, and here we go. It does several things. It says, it gives you the numbers you need for the equation of the line that is closest to fitting your data, and the very last item is R. That's your correlation coefficient. Our instructions say to round to 3 decimal places, so 0.957, and I won't round up. So my answer is 0.957. In a few minutes, we're going to get more things from that. Now, just ask you, would that be a good, is that a positive correlation? Yes, and it's a very strong one. Now I'm going to show you something that you do not have to do, but I want you to see it. The second of the y equals key is stat plot. And I'm going to, that was second of the y equals is stat plot, and I'm going to choose number 1 and I'm going to turn it on. So I'm going to choose on. Everything else is fine. It's going to get my x's from L1 and my y's from L2. So now I can do a second quit. I'm going to do a zoom, and this is, I've got this in some instructions. And you can do a zoom, going down. Whoops, oh my, I went way too far. I think it's a 9. Yes, zoom 9 is zoom stat. That will set your graphing window to be exactly right for this data. And then press enter. And I have something else in the y equals that I did not intend to have. Clear that out. So back to graph. There is my data. And you can see that there's a pretty strong correlation. All right. You didn't need to do that. You're not going to be asked to do that in class, but I wanted to show it to you. because we really haven't spent time using the graphing aspect of this calculator. All right, number 7, compute R. All right, how do we do it? Well, let's do second quit. Second quit always gets us back to the home screen. Make sure your home screen is always cleared off before you start doing something new. Want to put my data in, stat, edit. I'm just going to type over this data, and if I have some at the bottom, I'll delete them. All right, for the x's, I have 4, enter, 8, enter. I'm right over here. 4, 8, 6, enter, 7, enter, 3, enter, 2, enter. Okay, it was the same number of data items. That's good. Go to the right. Go all the way up, whoop, not on L2, but there, to the first entry, and put in 6, enter, 3, enter, 6, enter, 5, enter, 7, enter, 10, enter. Now, all I have to do is get the R value. I'm not going to go look at the scatter plot unless we just want to. So hit stat again. This time go right to calc. You're going to choose number 4, which is linreg, linear regression, the best line. Takes you to the home screen, verifies all the things. The X's are in L1, the Y's are in L2, and let's go down and calculate. There we go. What's your R value? It is, R is equal to negative 0.912. So for this one, there is a negative correlation. If you want to take a moment to look at it, there they are. All right. Let's look at number 8. We have a few things to do on this one. Make it a little bit smaller. All right. Use the data to the right. On the minutes a certain actor spends shirtless in a movie. Okay. This is minutes shirtless compared to opening weekend gross in millions of dollars. They're trying to find out if there is a correlation between these. And I think it would strongly depend on who the actor was. All right, but let's see. Determine the correlation coefficient, rounding to 2 decimal places. All right, 2 decimal places. I can do a second quit. I go to stat, edit, always stat, edit, and I have 0, enter, 0.9, enter. This one I have columns, that's nice. 1.6, enter, 1.8, enter, 13.4, enter. Now you want to be very careful because there's an extra data value left over from the other set, and I want to hit delete. If I don't, I will really distort my answer. It will be wrong. All right. For the gross in millions of dollars, 6.4, enter, 8.6, enter, 15.3, enter. Okay, come back. All right, 15.3, 17.4, enter, and 20.5, enter. There's an extra data value left over from the last time, and I need to make sure I get rid of those. Okay, so I've got my data, and I go back to stat. I go to the right to calc. I choose number 4 because it says linear regression, and hit enter till it gets down there to calculate. I don't know if your calculator will be like that, depends on your addition. And the R value to 2 decimal places is 0.73. Okay. Find the equation of the regression line for minutes the actor appears shirtless in the film and the film's opening weekend gross. Okay. This was on my screen. I just haven't used it. It says that the equation is in the form y equals a times x plus b. You are probably more familiar with y equals mx plus b, but they call the slope a. You know what? I'm going to drag this right over here. And of course, it did not go where I wanted it to. Come here. Where'd you go? Ah. Let's make it tiny. And now see if I can put it where I can see it. And the answer to that is probably no. All right, this was 0.73. I'd like to be able to refer to this. All right, so to find the equation, it's going to be y equals, they say round to 2 decimal places. So it's going to be 0.78x, you're filling in that, plus the b value, 10.87 if I round, 10.87. All right, now they asked me to answer a question. What opening weekend gross can we anticipate if the actor appears shirtless for 19 minutes? Okay, now we can use table with our calculator, or we can do this by hand. Let's see about doing it by hand, and then I'll show you how to use the table. All right, so they are giving me an x value of 19 minutes, so y equals 0.78 times 19 plus 10.87. Y is equal to, clear that off, 0.78 times 19 plus 10.87. Enter. And it says that we will have, if we round to 1 decimal place, we will get 25.7, and that will be millions of dollars. All right, I will show you, if you went to second, oh, never mind, I'm not even going to do it with the calculator. There are a lot of steps, and you're not used to using it, so we won't do that. We'll do this calculation by hand. All right? Let's do one more, and we'll answer these questions. All right, the data below shows the number of registered automatic weapons in thousands and the murder rate in murders per 100,000 for 8 random selected cities. All right, so we have so many automatic weapons measured in thousands, and we have the murder rate in hundreds of thousands. So we're going to see if there's a correlation. More automatic weapons, does it mean more murders? Or more automatic weapons, does it mean less murders? So, or is there no correlation? We'll clear our home screen, go to Stat, Edit, and start back over. Go back over to the first place in L1. I have 11.5 8.4, enter. 8.2, enter. 6.5, enter. 3.7, enter. 2.8, enter. 2.1, enter. 2.2, enter. 0.6, enter. You could put 0.6, it doesn't matter. Go to the right, go up to the top, but not on L2, come into the data. And we have 13.2, enter. 10.9, enter. 11.3, enter. 10.6, enter. 5.1, enter. 6.7, enter. 3.6, whoops, I didn't get the point in there. 0.6, enter. And 4.4, enter. You want to double check your data in your calculator because your answer is only as good as your data. In MyMathLab, you've got a little, more than one chance. On a test, you would want to make sure that you double checked this data. I am double checking my data right now. All right, I feel okay about that. Now I'm supposed to find the correlation coefficient. I will do stat. Now I'll go to calc based on the data I've entered. I want number 4, so I'll just click 4. Press enter on my screen. I don't know if you'll have to do that on yours. And the R value, we want it rounded to 2 places, is going to be 0.87. And of course this decided to go down here. It goes wherever it wants to go. All right, find the equation. The M value, well, the M value, the role that it plays in ours is A. So M is the same as A. I'll put a little, that's M. And we want to round to 2 places, so 0.88. The y-intercept, or B, is right here, 4.12. That means the equation, although they don't ask for it, it would be 0.88x plus 4.12. Approximate the murder rate in a state that has 15,000 registered weapons. So X is 15,000. So Y is equal to 0.88 times 15. I don't have to put the 1,000, that's implied, plus 4.12. Calculator, clear. 0.88 times 15 plus 4.12. And I get Y is 17.3, and that would be there are 17.3 murders per 100,000 people in that city. I'm just a little bit curious. I've still got my data in there, and if I do a Zoom 9, there's my data. Remember that the correlation coefficient was 0.87. It's a positive correlation. And I'm going to show you something else that you don't need to worry about doing. But if I put in 0.88x plus 4.12, whoops, I didn't get a plus in there, plus, I lost x plus, there we go, 4.12 and I look at the graph now, when you do a correlation, and when you do a regression, linear regression, it gives you the equation of what's called the best fit line. So you're not going to be doing this graphing piece of it, but I just wanted to show you, if you actually looked at the scatter plot of this data, did the regression with the calculator's help, and then looked at the actual graph of y equals mx plus b right here, this is what it looks like. Okay, so just using the calculator to find R and A and B, follow your instructions and do your homework on 12.6.